Alright, everybody, welcome back. So now I'm going to be focusing on 7th grade. And lastly, because I've been doing this alphabetical, I'm going to finish off with statistics and probability, which I know is not our favorite, a lot of us, but it's not that bad. It's just a little bit of extra reading, guys, but most of the time, like I said, for 6th and 8th grade and all levels of math, it's not that bad. Okay, we just got to read carefully and make sure if we have to double check, we double check, triple check if we have to. Okay, so let's go ahead and get started. So let's take a look. We have some dot plots. Okay, so a lot of tables to go with here. Yes or no questions, true or false questions. More tables. So then I got the box plots right there. Okay, not too bad. So more box plots. All right. And we go all the way to number 15. Okay. So let's go ahead and get started with this. So let's see. Aaron and Alex play basketball for their school. The table shows their points scored for the first 5 games of the season. Okay, so I guess we are comparing, right? Versus. So select true or false for each of them given about their points. The mean, the median, and the range. So we are comparing a lot of this stuff. So let's do the math. Do I have room? Yes, right there. Okay. So let's focus on Aaron first. So for Aaron, we're talking about the mean. The mean, and I have a calculator, yes. So let's go ahead and use that. For the mean, what do we got to do? We got to add up all the points and divide by 5. So let's see. I got 12 plus 13 plus 11 plus 14 plus 13. So for my mean, I got 63 total points divided by 5 games. So if I take 63, divide that by 5, I get 12.6 points per game. That's on average, right? That's the mean. So the median, I got to put this in order. So let's see. This reminds me of my 6th grade one that I did couple weeks ago. So let's see, a lot of the same steps here. So the smallest number is 11, then 12, then 13, then another 13, then 14. Okay, so to find the median, it's the one in the middle. So there's 2 on the left, 2 on the right. That is the median. And then lastly, to find the range, well, the range is from 11 to 14. So 14 minus 11 is 3. So that was Aaron. So now let's focus on Alex. I'm going to put this in order again. So if I'm looking at his points, I got 7, I got 8, I got 12, 16, 17, 12, 16, and 20. Now I'm going to do the mean first, so let's add those. 7 plus 8 plus 12 plus 16 plus 20. And I got 63. Okay, so it looks like the mean should be the same. So 12.6. Okay. All right. So what is after the median? The median is the one smack dab in the middle. So my median is 12, and my range is from 7 to 20. So 20 minus 7 equals 13. So now let's go ahead and compare what we have here. So the mean of Aaron, 12.6 versus 12.6 is more. No, they're the same. The median of Aaron is more. So the median was 13 versus 12. So yes, that's true. The median is bigger on that one. And lastly, the range of Aaron is more. So 3 versus 13, and that is false. All right, number 2. The dot plots below show the amount of time 2 different groups of students spent on their phone during class. Okay, don't do that. Instead of being on task. How much greater is the mean for group 1 than that of group 2? Round your answer to the nearest 10th. So this is where it gets tricky. Like, what do I do with all that info? That means you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 students. Okay, so 2 students had 10 and 10. 3 students had 20. You get what I'm saying? So I'm just going to add all those. Okay, so blah, 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 blah. Okay, and all I care about the mean. So I'm going to start. It's going to be a long one here. So I'm going to just double check this. So I got 10 plus 10 plus 20 plus 20 plus 20 plus 30 plus 30 plus 30 plus 30. There's 4 of them. Plus 140 plus 50 plus 50 plus 50. So I get a total of 390. I'm going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 390 divided by 13, and I get 30. So if I do the other one, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So divided by 16. And I got 3 zeros, so I don't really care. I got 10 plus 20 plus 20. Not 220. There we go. And then 3 30s. There's 3. Plus 4 40s. Okay, so plus 1, 2, 3. So there's my 4 40s. And there's 3 50s. So then my total is 450. Okay. So let's take 450, divide that by 16, and I get 28.125. So, how much greater is the mean for group 1? Well, it is greater, so I probably did the right counting. So in that case, I have to subtract. So 30 minus 28.125, so calculator time. So 30 minus 28.125, and I get a total of 1.875, but I got to round to the nearest tenth. So I got to round to that one, which means I got to check the 7. And because that one is bigger, or 5 or bigger, that means I got to round to 1.9. Okay. Next one, Kevin wants to start an anime club at his school to get a feel for how many students. Let's make this smaller so I can read this better. So to get a feel for how many students would like to join the club, he needs to create a random sample of students. What's the best way he should do this? Okay, so the topic is anime club. All right, cool. So, all right, I got it. So 25 students of his art class. Yeah, okay, anime. I could see that. A lot of kids I've seen drawing different characters. Okay. Closest friends? No, that's almost never the answer. Don't ask closest friends, okay? And the reason is usually it's biased, because think about it. If he wants an anime club, if he's into anime, maybe some of his friends are going to be in it as well. So it doesn't really help, right? If you want an unbiased, right? You want to see what's really going to happen. Random always helps. So random 7th graders, okay? And 25 random students from the entire school. So the question is, did he want it for his grade level or for the whole school? He wants to start an anime club at his school. So in this case, it should be the letter D. Okay, number 4. A magician is hired for your little brother's birthday party. He has a bag full of colored blocks. The bag has 8 blue. Okay, so I have 8 blue. What else? 4 purple and 6 yellow. Determine whether each event below is likely to happen. Choose true or false. So the probability. So probability is what you want over your total, okay, or what you have, basically. So what is the probability of purple? So the purple is 4. No, that is false. A lot of reasons like, what? It says 4 right there. Remember, probability is a fraction. It's 4 out of 8 plus 4 plus 6 is 18. So it's 4 out of 18. Okay, it's not just 4, it's 4 out of 18. The probability of pulling out a green marble is 0. Yes. Why is it 0? There are no green marbles. Okay. And the probability of pulling a blue block is 4 out of 9. Well, if I have blue, that's 8 out of 18. That is not 4 out of 9. But wait a minute. Are they trying to mess with me? Yes, be careful with fractions, because I notice that 9, if I divide the 18 by 2, I get 9. But if I do it to the 18, I have to do it to the 8. So 8 divided by 2 gives me 4. Hey, that's the same thing. So that one was true. All right, a new video game store just opened up and decided to attract customers by having a prize wheel with 4 equal sized sections. The table below shows the outcome for each of the 4 possible prizes. Based on the outcomes, enter the number of times you would expect to get a 10 off of 50. So I care about this one, okay? If it was spun 25 times. So I'm thinking about the last video I made with the ratios and proportions. So these should be a similar ratio. Okay, but what I mean by that is, what is your probability? In this case, it's out of how much? So I got 24 plus 30 plus 21, not 1, 21 plus 25. Hey, that's out of 100. So for my first outcome, right, I had 24, not 5, out of 100. But now I don't have 100 spins. I only have 25 spins. So then the question is, how much do I expect to get? So in other words, how did I get from 100 to now 25? I divided by 4. So if I do it to the bottom, I got to do it to the top. So now instead of getting it 24 times, I should only get it, should be 6, right? So 24 divided by 4, and I get 6. And that hopefully makes a little bit of sense, or a lot of sense, because 100 spins, you would expect to get it a lot more than if you only spun it 25, right? But you're supposed to be getting it the same amount of times proportionally to the amount of spins you have. Okay? All right. Number 6. Miriam bought a bag of lollipops. The bag had the following flavors: watermelon, grape, strawberry, apple, and mango. Okay. She's curious about how many lollipops of each flavor there are. So she does a little experiment. She pulls out a lollipop, records the flavor, and then puts it back. Okay, so that's important. Puts it back in the bag and shakes it. She does this 100 times. That kind of sounds like this, doesn't it? Use the data below to answer the questions. Okay. There are about 4 times as many watermelon lollipops than mango. Okay, the probability of handing out an apple lollipop is 1/4. Select the list that could represent the data from the experiment. Ooh, pues, mira. Okay. So I'm going to do the second one first because I like this fraction. And you'll see why in a little bit. So the first thing was out of 100, right? So 100 is nice because it's 100%, right? If I got 3 out of 100, that's 3%. If I got 64 out of 100, it's 64%. That's the probability, right? That's the percentage. So in this case, the probability of handing out an apple was 1/4. So how did I get from 100 to 4? Well, the reason I said 1/4 because if I divide by 25, you get it 25 cents. There are 4 quarters in 100. So if I go backwards, times 25, out of 100 times that she went in there to get a lollipop, 25 of those should have been an apple. Okay? So if it's at 100, 25 apples. There are 4 times as many watermelons as there are mango. So let's say, how does that work? Okay, so 4 times as many watermelons as there are mango. Does that make sense if I write it that way? Because there should be more watermelon. No. So it's supposed to be the other way. So let's just try this. If I have 40 watermelons, that's 10 mangoes. And again, I'm just plugging in numbers here. So that should make sense because if that has 10 and the watermelon will be 4 times, okay. So that's another possibility. So now let's look at our information here. So watermelon, 4. I care about watermelon. Let's start with that one. And mango was 12. No, there should be more watermelon, so that's wrong. So 8 and 4. No, that is double, so that's wrong. Oh, this is going to be easier. I think I did it the long way. So watermelon 13, mango 3. 3 times 4. That gets me close. But so does that one. 3 times 4 gives me close-ish. I think C is probably better. But let's just check the other one. Apple. 1/4 of it was apple. So for my apple, then I want to focus on apple had 7 versus 11. So this one had 7 out of what? So 7 out of, let's see, 10 plus 8 plus 12 plus 7 plus 3, and that's out of 40. So what's 7 divided by 40? That is not 0.25, that's 0.175. Let's do the top one. I had 13, I had 5, I had 8, I had 11, and 3. So this is also out of 40, but I had 11 apples. So if I do 11 divided by 40, that gives me 0.275. And then 1/4 is 0.25. So the closest one is C. Okay, so I overdid it at the beginning. I'm sorry. All right. Rebecca took 6-sided dice and decided to paint each side with a color. She rolled a dice a total of 120 times. So does that work if I add those? Let's just double check. 84 plus 25 plus 11. Yes, so that equals 120 if I add those. Based on the table, how many sides of Rebecca's dice are most likely red? So if I want red, I want 84 out of 120. So if I do 84 divided by 120, that equals 0.7 exactly. So if I think about dice, right, there are 6 sides. So I have to get close to 0.7. So is it 1 out of 6? Or 2 out of 6? Or 3 out of 6? You get what I'm saying? 4 out of 6? 5 out of 6. Because 6 out of 6 is 100, right? So if it's more than half, because it's 0.7, it can't be those. So if I do 4 divided by 6, that gives me 0.6666666. So that's close to 0.7. If I do 5 divided by 6, that's 0.83333333. So which one is closer? This one is going to be way closer. Okay. So in this case, 4 out of those 6 sides should have been red. Okay. And that should make sense because the majority of the outcomes, right? 84 out of 120, that's a lot. So 4 out of 6 sides should be red. That sounds okay to me. All right, number 8. A spinner with 4 equal parts, red, yellow, orange, and blue, or red, orange, yellow, blue, is spun twice. Enter the probability that it will land on blue twice in a row. So here's the kicker. So I'm going to spin it the first time. Then I'm going to spin it the second time. So for the first time, I'm going to get blue. So there are 4 equal parts, red, orange, and blue. So for my blue, it was 1 out of 4. Then I want to blue again. So if I have blue again, that's another 1 out of 4. So the thing is, I don't add those. I have to multiply my probabilities. So the first probability is 1 out of 4. Then I have to multiply times 1 over 4 again. So let's do that. 1 divided by 4 times 1 divided by 4. And I get, can I put that as a fraction? 1 over 16. Or you could use the decimal. Okay. So either one would have been correct because it didn't tell me to put a percent or decimal or fraction. All right, the table below shows the outcome of someone rolling a 6-sided dice. Based on the outcomes, enter the number of times you would expect to roll a 4 if you roll 30 times. So again, more ratios, okay, and fractions, equivalent fractions here, guys. So let's see what I'm talking about. I assume my total is probably 100. Let's check. 22 plus 16 plus 27 plus 10 plus 14 plus 11 is 100. So for a 4, the first one was 10 out of 100. So what would happen if you wanted to roll a 30? Or if you did it 30 times instead of 100 then? It should be the same-ish amount. So the question is, how did I get to 30? Well, if I think about it, 10 out of 100, if I put it on my calculator, is 0.1. Or, as a fraction, is 1 over 10. Now this makes it a lot easier because if it's 1 out of 10, how do I get to 30? Well, I multiply times 3. So what do I do with the 1? I multiply times 3. So then my answer should be 3 times. And that should make sense, right? Because 10 out of 100 is really small. So if it's out of 30, I should also get a small number. So if I do 3 divided by 30, guess what? I also get 0.1, aka 1 over 10. So those are fine. Number 10. So let's clear that. The 2 7th grade classes at school are competing in a fundraiser to see how many canned goods they can collect each day to donate. The box plots below show the data for each class. How much greater is the range for class 2? That's it? Okay. Remember, the range is from the smallest to the largest number. So all I got to do is subtract, okay? So for my first one, for class 1, it is 35 minus 0, which is 35. For class 2, I got 50 and 5, so 50 minus 5 is 45. So 45 versus 35. So how much greater is the range for class 2? That makes sense. The range should be longer or bigger. So if I subtract those, 45 minus 35, that equals 10. Number 11. Okay. Almost there, guys. So let's see. The varsity and junior varsity soccer team squads at your school have just been decided. Oh, whew. The coach is ready to hand out the team jerseys for the year. In a box, he has 5 small. Okay, do I have room here? I'm going to go right here. So I have 5 small, 8 medium, 11 large, and 4 extra large. Each player on the team reaches in randomly, that's important, to get their jersey. Determine the likelihood of each event below and select true or false for each statement. So every time we've done this, we always have a total, right? Anytime you have probability, right, it has to have a total. So 5 plus 8 plus 11 plus 4, and then I get 28. Does that sound right? Okay, I guess. So it's out of 28. So Evan wears a small. It is highly likely that she will get her shirt size. So if it's a small, it's 5 out of 28. Actually, let's just do that then. 5 out of 28. Let's make each one into a percent. So 5 divided by 28, that equals 0.1785. In other words, 17.85%. For a medium, I have 8 out of 28. So 8 divided by 28, and I get 28.57%. Then I have for a large, I have 11 out of 28. So 11 divided by 28, 39.28%. And finally, the 4XL, so 4 out of 28. So 4 divided by 28, and I get 14.28%. So Evan wears a small, so let's go back to this. It is highly likely that she will get it. So is 17% highly likely? No. Okay, that's pretty low. So let's try another one. Let's see. Miriam wears a medium or a large. So medium or large, that means you have to combine them. So that gives me these two. Okay. So again, just so you know, this was a small, medium, large, or extra large. So will that be highly likely? I think it should be, right? Let's see. 28.57 plus 39.28. Yeah, that's like more than 2/3. So I think that should be highly likely. So the question I have though is that good enough for highly likely? Hmm. I'm gonna say yes. Okay. Ugh. This is one of those annoying ones because again, it depends on who's answering. I would hope that if they gave you something like this, again, I made this up, it would be like obvious. It would be like 90% chance. You know what I mean? That's like okay, you're basically gonna get that. To me, 67%, that's that's good odds. Okay, that's a good probability that you're gonna. That to me, that is highly likely. All right. So I don't know where the cutoff is. So I'm gonna say yes, that's highly likely. Again, hopefully on yours, what percent is that? I don't know. Okay. So after all the jerseys were given out, about a fourth of the players got a medium. So my medium is 28%. Is that about a fourth? Yeah, that's about a fourth. Okay, it's close enough. All right, number 13 or 12. 12. Lila and Desiree's favorite chips are Doritos, Dynamita. What the heck is that? I never heard of those. Okay. Oh, that's right. Those are those Chafataki ones that I seen. Oh, okay, I remember now when they told me. Yeah, yeah. I had to Google that one because I was like, I had never heard of those. Okay, but that's what they said. Okay. The box plots below show how many bags of chips each one eats a week over a span of 6 months. Okay, so per week for 6 months. All right. So there they are. We got to compare. So what do I care about? Interquartile range, median, and range. So the interquartile range is right here for both of them. So it's the range from 3 to 8. So that's 5. And then for Desiree, it's 3 to 8, which is 5. So is one larger than the other? No, that is false. Okay. What's next? The median. The median is smack dab in the middle. So that's this line right there. That's 6 point something versus 4 point something. So the median is larger for. Oh, I forgot to change the names. I gotta fix those. And they will be fixed over there. So I switched it to Lila. Okay. Sorry about that. So Lila, and Lila. So let me read it again just to make sure. The interquartile range is larger for Lila than Desiree. No, they're the same. The median is larger for Lila. Yes, because it's 6 point something versus 4 point something. So that one is true. And then lastly, the range is larger for Lila. So the range for the whole thing is 10 versus 9 minus 2 is 7. So, yes, Lila's is larger. Okay, so there we go. Okay, number 13. Your teacher wants to reward all her classes with either ice cream or popcorn because of all their hard work during the state testing. What is the best method to sample what the students might want as a reward? Okay, so let's look at this. So it's ice cream or popcorn, it's a reward, and it's all her classes, not the whole school, just her classes. So the teacher can ask random students at the entrance of school in the morning as students enter the class or the school. Okay, I like the word random. The teacher can ask the parents dropping off the kids in the morning. So is that who? No, I know that for sure. No. Okay, well, parents would know, but no, I think the kids would know a lot better, right? What their favorite is. The teacher can ask every fifth person that walks into her class. Okay. And the teacher can ask a group of kids that hang out outside her classroom during lunch. So I like this whole every fifth because that's random. It has to be her classes. So I think the best option would be C here. Okay. And last one. No, I got two more. Yes, two more, guys. All right. Let's finish strong here. Your teacher wants to bring some snacks for the after school tutoring session. Damn, your teacher is nice. Okay, he's like bribing you guys. He will be having. He surveys one of his classes on their preferences because it serves as a good representative sample for all seventh graders. Okay, so I guess his classes is a good representation of all seventh grade. Okay, the table below shows the results. Choose all statements. So if there's four, I'm going to pick 2 or 3 that are valid based on the results. So let's look. A lot of this is totals, right? So let's see what the total was. So 25 plus 10 plus 8 plus 7. So 50. That's a nice number. So again, it's 25 out of 50, out of 50, out of 50, out of 50. So 8% of the students surveyed preferred Sour Patch. Now I gotta do it in percentages. So that means I gotta put this fractions in percentage. So 25 divided by 50 is 0.5, which is 50%. 10 divided by 50 is 0.2, which is 20%. And then this one will be 16%, and that'll be 14%. If you don't get the pattern here, because remember I told you your percentage was out of 100, right? Well, if these are all out of 50, how do I get it to 100? I just gotta multiply times 2. So that gives me my total percentage. All right, so now let's go back and see how this helps me, at least for the first two probably. So 8% of the students preferred Sour Patch. Sour Patch, it is not 8, it is 16. So that is wrong. 64% of the students surveyed preferred Gummy Bears. So Gummy Bears was 50%. So that is wrong. Okay. So here's the kicker, right? I'm picking 2 or 3. Now, I said, right, it has to be 2 or 3. And if I know the first 2 are wrong, most likely the last 2 should be correct. And I always say this, but again, as I told you before today, I made up the test. So teachers make mistakes. So let's see. I hope it works out this way. I usually try my best to have it. So let's see. If 150 7th grade students were surveyed, you could expect 30 to prefer Kit Kats. So now I care about Kit Kats. So now I got to compare. So for Kit Kats, I had 10 out of 50 versus whatever number out of 150. So how did I get to 150? I multiplied times 3. So if I do that to the 10, I should get 30. So is that what it was? Yes. So that one works out. Okay. And my last one. If a group of 7th grade students had 13, and again, I assume this one's got to be it, right? So let's see, if a group of 7th grade students had 13 who preferred Sour Patch, okay, let me highlight. I like my colors here. So 13 who preferred Sour Patch, then you could expect 12 to prefer Starburst. Oh, I see what they did here. So they said if 13 prefer Sour Patch, then 12. Why? Because one had 8 and the other one had 7. No, that is not true. So where did I screw up as a teacher? ¿Qué pasó? And again, this is a good, let's make this a learning opportunity here. because me as a student, I'm always a student first in my head. I probably screwed up somewhere as a student, okay? Because I'm pretty sure I should have picked 2 or 3, and if I only picked 1, I have to go back and reread them. I know we're at the end. I know we want to just finish. I know we want to just say, who cares? Let's just move on. But guys, we already did all this work. Just take your time. Let's go back. And as I'm looking at this while I'm explaining to you, I know exactly where I screwed up. Let's look at the third one. No, the second one. Some of you guys maybe already caught it. It said gummy bears. Where did I screw up? Or Starburst. So that's 50% and 14%. And guess what? That gives me 64. So yeah, that one is true. So this one was wrong, and now I am happy because those are the 2 that I know are correct now, after I figured out that I screwed up somewhere. So yeah, okay, learning opportunity. Like I said, right? I'm sure that'll happen to a few of us, or a few of you guys. Just keep that in mind, okay? All right, last one. Last one, finally. I'm going to get some food because I'm hungry. All right, moving on. You and your friends are playing categories. My wife's favorite game to play in school. Okay, you guys too. You get riled up with this one, and have a 26-sided dice that you roll to see which letter from the alphabet you will use for your list. After 5 games, you notice that you rolled a letter R twice. That's gotta be rare because it's 26 sides. Excuse me. The predicted probability of rolling an R is 1 out of 26 because, again, there's only 1 R in the alphabet. Okay, so yeah, that makes sense. So I'm happy so far. Everything's making sense. Select the statement that best describes why the frequency is different from the predicted probability. Okay. So you got to know the difference. And they waited till the end for this one. All right. So frequency is how often it happens. So that's what happens. Like in real life. The predicted probability is what's supposed to happen. So for example, if I flip the coin, right? I mean, I would expect to get heads, and on the next one, I should probably get tails, right? Because I got heads first, so I should probably get tails. But sometimes you guys will get tails, and you're like, what the heck? That is my frequency. I'm only getting tails, and I don't know what's happening, right? It should be a 50-50. So that's kind of what's happening here. If I roll it 5 times, I should get only 5 different letters, right? That's kind of what it's saying. But this one told me I got R twice. And I should have gotten R only once every 26 rolls. So you got R every 26 rolls. This one, I got it after 5 rolls. Okay? So let's see. They are different because 1 out of 26 is different than 2 out of 5. I mean, I guess that's true. Okay. Yeah. Okay, moving on. So I'm like, okay. They are different because predicted probability is wrong. Is the predicted probability wrong? No, it is right. It is 1 out of 26. They are different because the frequency probability is wrong. They didn't give me the frequency probability. That doesn't say anything. The frequency probability, just like the one earlier today, I think it was like the 1/4 and 1/4, right? Well, this is 1 out of 26, and this is 1 out of 26. Okay? All right, they are different because, okay, so that's wrong. They are different because the sample size is too small. Okay. This one I've heard a bunch of times in the textbook. So notice what I said here. If I had rolled a bunch of times, right? Like if I had kept going for tails, heads, and gotten heads, and heads, Now I would have gotten 5 out of 10 and 5 out of 10, which makes sense because that's a 50-50. So if I had kept rolling, eventually to 72, not 72, what is it, 26 and 26 is 52, right? 52 rolls, and still only had 2 R's, then I would have had the predicted probability be the same as the frequency. Assuming I didn't get any R's, but I rolled it 52 times. So if I had kept going, I could have still been okay. Now again, I could have gotten another R, but I could have just kept going and going and going until it stayed. So eventually, it should match. So that's the idea. What's supposed to happen and what actually happens will eventually match if you keep rolling. So if you keep flipping the coin, eventually it'll be 50-50. If you keep spinning or rolling the dice, eventually everything will be 1 out of 6. Okay? That's what it's saying here. If I keep rolling this dice, it'll eventually always be 1 out of 26. It might be a couple hundred or thousands or millions. I don't know. But eventually it should be the same. I just got to keep going. So this one was too small. Ugh. That was a tough one for the end. Okay, so hopefully that little mini lesson explanation helped out a little bit. Okay, because I've seen this in your textbook quite a few times as the answer, right? You just got to keep going for it to eventually be the same. Your probability and your frequency. Your expected versus what's supposed to happen. I mean, your expected versus what actually happens. Anyways, quick recap. I know you probably already turned it off, but that's okay. So for this one, we have a lot of fractions, right? Make sure you have totals. It's always what you want over a total just to get stuff ready. You got to make sure you turn things into percents because that helps you figure out stuff a lot faster. And that was essentially it. We got some box plots you got to know some vocab too. Okay. And a lot of it was pretty much very similar, right? A lot of tables for statistics and probability, guys. So you got to make sure you know what to do with them. And like I said, most of the time, it's out of a total, right? It's what you got over a total. A lot of this stuff today. Okay, so that's it. Until next time.